All right, afternoon, everyone. We'll get started. Hope everyone enjoyed lunch. We're going to have a private well driller's perspective and panel discussion. We have three different drillers here with us today. They're going to each give a presentation, about 20 minutes each. I'm going to start with David Henrich from Bergerson and Caswell out of Maple Plain, Minnesota.
All right, so Steve pulls this panel together for every one of the conferences here just to give you guys, well, something to do with your rotten tomatoes that you store up all year. So we're up here to take the abuse, so feel free to, at the end, go ahead, unleash all the hard questions. One thing I'll note, I was looking at the question over lunch, some of the challenges, seeing this group recognize that workforce is like the key and most significant challenge is really, it's great that everybody realizes that, because everybody says, why can't we, it's like, well, there's only so many hands and there's a lot of work to do. And frankly, right now in our industry, it's still receding a little bit. So hopefully we can do something to make people, improve the perception of this industry and want to be more a part of it over time. And so it's good that everybody sees that. So one of the talks one of the options that Steve had kind of kicked out was to maybe have someone talk a little bit about data centers, groundwater. And I've got a little extra tail on it, talking about maybe thinking about some of the other things we could be doing to, help data centers be more conscious with the resources that they're using. So, as I was introduced, David Henrich, President, Bergerson Caswell Incorporated. We're a water well contracting outfit out of Maple Plain, Minnesota, been around since 1948. There's been a Henrich at Bergerson Caswell since 1949 when my grandfather started. In 2018, I was the president of the National Groundwater Association, 2019, president of the Minnesota Water Well Association. I've spent almost 16 years on the Advisory Council for Wells and Borings with the Department of Health. I'm currently the chair of that committee. I've spent a lot of time working in federal and state level water policy through volunteer activities through the NGWA and the Minnesota Water Well Association. So I've spent a lot of time kind of trying to understand, what we do, why we do it, and how what we do affects the rest of the world. And one of the things that's coming up right now that is a direct intersection is data centers. Anybody in here heard about data centers as an issue in your state? Right? Everybody has. And so I started hearing, so my expertise is I'm pretty good with water supply wells. I'm exceptionally good with geothermal systems. I've got two other smaller companies that deal with, one company reps and supports and develops the ground loop design software, which is a design program for designing closed loop geothermal systems. We've been helping develop that product for about 20 years. I also have another company that builds thermal conductivity test equipment, servicing also the geothermal industry. So my intelligence on the geothermal, like how energy models come together and what people are trying to do in terms of heat transfer, which is all the data center problem is. I can come at it from a couple of different perspectives to help people think about what we can be doing. And that all kind of fed into working on a series of articles in the Water Well Journal earlier this year about data centers, water use, what are some options? Because as I was reading a lot of the issues that were coming to the forefront on data centers middle of last year. And I'd been working on data center things for 10 or so years on a much smaller scale, as people are trying to figure out how could we incorporate geothermal with thermal rejection and have that work over time. It just kind of evolved into something that grew much more rapidly and became much more present in the front of people's minds. So I can kind of understand where people are coming from, because we already went through this cycle, right? So we'll take downtown Minneapolis. Downtown Minneapolis used to cool all of their buildings with wells in the ground that they pumped water out of the ground through the building, dumped it in the river, let it go down to Louisiana. And of course, as we're doing that, we're watching the water tables recede. So data centers, of course, give us the opportunity to ride that carousel one more time, which don't. We don't want to do that. So I can understand everybody's reaction to wanting to be water smart, because we need to. Groundwater is an incredibly valuable and limited resource. We shouldn't be blowing it on cooling facilities. And so in this talk, I'm going to kind of go through what the problem is, and then some other solutions that maybe can get us away from having to use, actually functionally consume water to help control the energy requirements for these facilities. So they really have become a flashpoint topic. And like I said, Dr. Bill Alley, Chuck Jobe, and then little guy David Henrich here. Bill's the chief scientist at NGWA. Chuck Jobe run a section of the EPA for many years in the 2000s, 2010s, and somehow I managed to say something smart enough to be included in their article set. But one of the things that as Chuck was doing a lot of the background research on this, they came up with this, with this stat, or this narrative on consumption, which is on-site water consumption by data centers was estimated to total about 17 billion gallons nationally in 2023. Annual water usage can vary from 110 million gallons for a mid-sized center to 108 billion gallons for a large data center. The latter is comparable to the water use of a medium-sized town. Kind of a scary thought. The U.S. Department of Energy estimates that by 2028, total annual on-site water consumption could double or even quadruple the 2023 levels, and they probably shot low. The growth of AI, which uses larger and more complex chips, and therefore needs more power, and it heightens the concerns about cooling water demands. And so, there's been some knowledge about this topic for a while. It's just now coming to the point where the results of that, of these installations are starting to show up when we hear about, data centers like in Oregon that are using 30 or 40% of all of a town's water supply. And so there's all these things that have kind of come to the forefront that have brought this, to be a front and center issue. But the one thing I was noticing last year as everybody was talking about the issues, everybody was really capable of listing out the problems, really capable of listing out the problems. Everybody was not really looking for how can we fix this? What are the alternatives? What else could we be doing? Or maybe we'll just stop building them altogether, which kind of is, anybody here think we're not going to build data centers somewhere? Okay, well, unanimous again. Okay, so they're going to happen, so how can we do this in a smarter way? And groundwater, and this is a topic that we've worked on for a long time through the National Groundwater Association, is thinking about, aquifers and groundwater as infrastructure, not just, a resource to mine, but things like managed aquifer recharge, aquifer storage and recovery. If we really think about how we keep the checkbooks balanced, we can think about the actual development of groundwater supplies in a much more resilient manner. So data centers, they aren't just one thing. They have come in a very wide variety of topics, a wide variety of sizes and uses. So you've got everything from modular systems, which it's amazing to think that they literally could just pull these things in by the container, plug them all together, put them to an energy source and a cooling source, and put them to work. But that's one set. You got the edge micros, same kind of modular design. Then you have enterprise type data centers, which could be everything from a corporate data center to small end node systems. You've got co-located data centers where they literally build facilities that are racking up processing capacity for a wide variety of people who are trying to compute. And then you have hyperscale. And this is the one that everybody thinks about and ends up kind of being the target for a lot of the policy proposals that we're seeing that are kind of putting limits, because everybody kind of compares a data center to a hyperscale data center, even though hyperscale data centers are 1 out of 40 or 50, right? There's a lot more enterprise co-locations and edge micros, and those ones use a lot less water. So even from understanding the real problem, it's not a one-size-fits-all situation. It's good to understand that there's some questions we should be asking when people are looking to build data centers. what are you going to be using it for? How much capacity are you looking to draw? And there's other limitations, like can you even get enough energy to run one of that scale in this location? Okay, so one of the things that people don't necessarily think about is that data center developers are already aware of the damage that running water through these facilities can, what it can impose on the environment. So this is actually one of the better diagrams that I've seen that kind of shows what more modern data centers are really designing themselves to look like, which is to use air-cooled systems. So they can use, they're not actually functionally consuming a lot of groundwater or water in general, but the trade-off there is they're trying to reject heat, the peak load with the worst time to try to heat sink with the outside. So your kilowatt demand goes through the roof. So why they've looked at water-based systems, because it brings their energy profile down substantially, 50, 60, 70% reduction by being able to pass a cooling fluid through the system. So another thing to think about these systems, they do produce a lot of heat. And I've always been amused in the geothermal industry when people talk about waste heat. I mean, you're literally talking about waste energy. I mean, heat is energy. And so as we're thinking about heat, we should be thinking about potential beneficial uses for that heat. So we're starting to see purple pipe networks. We're starting to see thermal energy networks come into kind of things that are truly being evaluated this day and age. Data centers, when you think about facilities that do, especially in northern climates, facilities that do require heat, if you could plug a data center into a thermal energy network that was short on heat, you can really cover that load just from a data center. So there's some ways to think about how do we manage the thermal loads that data centers do produce. And then of course there's this concept of could geothermal be an option? And the answer is yes, and I'll actually go into a system that we installed in 2014 in southern Minnesota as kind of a case in point. But why the energy management? So this is why data centers are hard to condition, because conventionally, this is what an energy model would look like. So this is, if you're thinking about this building, it's got a profile, something similar to this. It's got some heating demands in the wintertime, and then as spring rolls around, eventually rolls into cooling demand, and then back into heating demand. So you have this nice cyclical relationship. And why geothermal systems work really well with this is because you can use the earth as a kind of a thermal battery. And so it has this lead lag effect. You can reuse some of the heat over time. But at the end of the day, you can much more efficiently work with an energy profile that looks like that. Now, data centers are all one way, right? They're just producing heat. And so there's no functional reuse of that heat inside of these systems, which is why you've seen a very conventional approach to how they want to manage the thermal loads. And so it's really important that, so where we see even in a facility like this that's going to have peak usage even throughout a week, and that's why you see some of the blank spaces in between all the other tall bars. A data center probably is more like that, right? It just covers up everything. It's just all thermal load all of the time. And it's why it becomes really challenging even for conventional geothermal systems to be able to dissipate this much heat in the soil, in the earth. It's all one way. There's no reclaim on that heat, and it just keeps on pushing in one direction. And so this is what happens in a loop field, a conventional loop field over time, is that that energy constantly going to the ground raises groundwater temperatures. So these are the entering water temperature graphs that the equipment in the facility would operate like. The ground temperature is probably lagging that substantially because the earth has an immense ability to dissipate energy over time. But you are pushing it, and everybody, the other thing I get a chuckle out of, especially being just west of Minneapolis, is people have a tendency to go, well, what about thermal pollution? I'm like, well, we probably should take a wrecking ball to every urban environment then too, because if you go study the groundwater temperature underneath cities, they have a tendency to be 5 to 6 degrees warmer in ground temperature than everything that surrounds them. that thermal bubble that exists in urban environments doesn't stop at the surface. You know, we've kind of created thermal pollution issues out of other ways, but there's ways through these types of, through geothermal systems that we can actually manage that over time, and I'll kind of catch that on one of the next slides here. So if we truly want to make it so data centers don't use any water or reduce the use of water, trying to figure out a more advantageous heat sink than an already hot environment is going to be required, because the kilowatt demand that using the air, hot air as a heat sink is incredibly inefficient. I mean, it literally raises the energy demands of a data center by 30%. And so when you think about that relationship for a second, it's like, good, we stopped them from using any water. What do you mean they just took up 30% more power off of our power grid? Right? So there's this balance you're trying to maintain between efficient production and use in these facilities and what we can do to reduce the water consumption. Geothermal systems can cover both. They can, by giving an advantageous thermal sink, the earth, for these systems, they can reduce kilowatt consumption for the cooling systems, and at the same time eliminate groundwater use. And then there's even some more kind of, as you think about things like pump and injection systems. So we take a place like South Washington County in Minnesota, where PFAS is all over the place, and we're thinking, how do you clean groundwater? Well, if you put a pump and injection system in for a data center, and you put a GAC plant and some other water cleaning tools in between supply and injection, you could functionally turn some of these facilities into groundwater remediation projects. And so as we're working with groundwater, there's other things that we can be doing if people start thinking about solutions and what else we can do with those solutions. And so geothermal options, conventional closed loop, pump and injection systems, submerged closed loop heat exchangers. Conventional closed loop systems rely on conductive heat transfer, therefore are always going to have some inherent limitations when you're trying to reject heat nonstop. Pump and injection systems, submerged closed loop heat exchangers, these are more convective systems. And these are the kind of technologies that data centers are most likely to be engaging with because of the capacity that they can develop. Cons, of course, on the pump and injection systems, you have to have high production aquifers. You actually have to have groundwater availability. And those are really the thing there. People try to find that one-size-fits-all solution. The reality is it is a site-by-site situation in order to evaluate any of these geothermal options. So when we think about the three options that were on the previous slide, you've got in the upper left-hand corner, you have submerged closed-loop heat exchangers, which is a novel approach to thinking about how we can interact with our soils in order to create a geothermal system. So it's a submerged closed-loop heat exchanger that pumps water, from a lower part of the aquifer through a heat exchanger into the upper part of the aquifer, and that convection allows you to transmit a lot of energy through one well. It's pretty remarkable technology. There's actually over 100 of these installed in Minnesota now. It's proving to be a very viable option, especially for places that don't have a lot of footprint. The conventional geothermal systems take up a lot of space, and things like submerged closed-loop heat exchangers don't. Similarly, in the lower right-hand corner, that's the injection wells for a 7,000 gallon a minute pump and injection system in Welch, Minnesota. And that thing's capable of something like 15,000 tons of capacity, which is a massive heat transfer system. So what I'm saying is there are high capacity networks out there for being able to transmit large amounts of heat without consuming water. Lower left-hand corner was a horizontal loop field that was installed for Hormel down in Blooming Prairie in Minnesota, and that one's interesting because that's a horizontal loop field. So when you talk about thermal load management, conventionally you wouldn't think, well, why would you use a horizontal loop field? It's not exactly noted to be the most resilient type of closed-loop geothermal system. But when you're in Minnesota and your problem is rejecting heat, and you take a horizontal loop field and you bury it very close to the surface, what happens to all that thermal buildup in January and February? It's gone, right? And so it's just going to take a more intelligent approach as people think about how can we apply these types of solutions to what's becoming a pretty big societal problem. Some of those newer options, for those of us that do care about groundwater, the nice thing is that things like submerged closed loop heat exchangers, pump and injection systems, these are not things that run-of-the-mill water well contractors can just go out and do. So most of the submerged closed loop heat exchanger applications that we run are 12-inch completed wells. That's one of our rigs right there, a DR24HD. The thing is insanely powerful and very complicated to operate. And so you end up working with, I think what people in this room would recognize as kind of your go-to contractors in the area, the people that do actually put a lot of time and effort into learning and knowing more about what they do. So some of those higher options, although they come with some other inherent risks, are generally being installed by people that have similarly shown a lot of dedication to the industry they're working in. And so another thing that's going to keep these systems kind of at the forefront is that there's a geothermal tax credit available for commercial facilities until 2035. So as you think about, data centers, and you think about the need, which is pretty immense, and then you have a mechanism that will help afford the solution, and you can pull that all together in a package. It means we're probably going to see a lot of people eventually coming around to look at these options, and a lot of the people in our industry are going to be trying to help figure out how do we make all this happen? What resources do we have available? But at the end of the day, if our concern is to reduce groundwater use or reduce water use in general, well, here's a mechanism to do it. Some of the other stuff you have to figure out around the fringe absolutely exists, but it's a path. And it's really, as we think about preserving and protecting groundwater, getting people to solutions that don't involve consuming a very precious resource, I think are things that we need to be directing people towards. About 6 minutes. Okay, well, that's kind of, I guess I powered through better than I thought. So I'm just going to pitch that over to Todd and we'll leave a little more.
Dave, actually, it was supposed to be 20 minutes, right? So not 30. Each of you talk for 20 minutes and then we do the questions.
Okay. Then I'm in good shape.
Sorry, I guess I don't know what I'm doing. Okay. Okay, so next up is Todd Hunter from Boulder Groundwater Services, LLC, out of Boulder, Colorado.
Good afternoon, everyone. Importance of geothermal rules for groundwater protection. I call it a dilemma, right? Everyone in this room understands that when we're drilling a water well, constructing a water well, be it a horizontal, be it a vertical, a surface water supply, we all have impact, right? We all do things that we may or may not have wished we did when it's all said and done. So what I've done for a very long period of time is try to address the primary, how do we not mess it up? So I'm Todd Hunter. I'm the current owner of Boulder Geothermal Water and Solar. I just sold my company that started actually in 1948 in Boulder, Colorado. I worked for the original owner's nephew from 1980 till about 1990. After 1990, went to work for U.S. Geological Survey and traveled all over the United States and Alaska doing research, drilling, water quality assessments, resource assessments, coal bed methane, climate study. So I spent a lot of time on a drill rig. Came back into Boulder, Colorado in early 2000, actually late 99, and agreed with the purchase of my existing business, or past business now. Sold it in January of this year. I now am a W-2 employee for the first time in 25 plus years. I also have a 1099 agreement with the individuals that I sold to. to kind of help them as a strategic advisor. So that's my background, 47 years, diverse and unique experience, 38 states, Alaska, the Aleutian chain. I put drill rigs on airplanes. I put drill rigs on boats up rivers to north of the Arctic Circle. We've drilled on ice. We've drilled on piers. We did projects in the middle of Death Valley National Monument. So I've got a pretty good understanding of, you know, how quickly you can mess things up if you don't pay attention. Right now, I'm a current member on the Board of Examiners. Governor Polis, the governor of Colorado, appointed me to this position. I think I'm 2 years into my second four-year term. But I'm one of 6 individuals now, and we'll talk a bit about the addition to our board. But we're basically tasked with providing oversight, rules and regulations, writing rules and regulations, and working with division staff to administer those rules. So I've been involved, you know, pretty heavily. Anyone who knows me knows that I've been involved in the water well industry with rules and regulations since 2009. I mean, my passion has been rules and regulations for 2009. There's a lot of drillers in the country that don't necessarily agree with rules and regulations. I personally have my own opinion, and I think rules and regulations are a very good thing. I think everyone in that room or in this room would agree. The BOE, basically, we're tasked with one simple task in my mind, by statute: don't mess it up. So I started my talk with don't mess it up. That's kind of where I'm going to finish my talk. Don't mess it up. I spent 10 years on the board of directors at the National Groundwater Association. I was president of the National Groundwater Association. Actually, David was my president-elect when I was president, so he and I kind of came through the ranks at NGWA at about the same time. We've done a lot of this kind of thing together. So current rules and regulations in the state of Colorado, as it stands right now, there's a geothermal set of rules and there's a water well set of rules. The water well set of rules, I've been involved since 2009 with 3 different revisions in the rules. And every single revision since 2009, I've been an active proponent of grout. Grout is our friend. Grout is the savior that's going to make all this stuff work. So current rules and regulations in Colorado allow for a geothermal contractor to get 1 permit in the state and then just identify, you know, sometimes 50 wells on 1 project under 1 permit. And there is oversight, and the oversight is that they will fill out a report at the end of the day that gives them all the detail on the hydrogeology, on the geology. How did they grout it? How did they build this product, right, that had numerous boreholes on 1 particular location on 1 permit with no oversight? So what we're looking at doing now, I think, there's some new rules and regulations coming along. The BOE has a new additional member who is now a geothermal taskmaster, if you will, Terry Proffer. Probably those of you involved in the industry, he's known nationwide for his influence and input into the geothermal industry. So hopefully we're going to be able to, as a group of 6 now, which is, you know, funny for a board, right? You would like a board with odd numbers rather than even numbers. This particular board, we have the Division of Water Resources, state engineer, assistant state engineer actually sits on the board. We have an engineer proper who's a geologist and an engineer. And we've got 2 water well contractors. We've got a geothermal contractor, and then we have CDPHE. So we have 6 different hats at the table. All of them ideally are chasing the same challenge, you know, don't mess it up. The annual permit allows that geothermal contractor to do 100 wells, 1,000 wells, you know, 5,000 wells a year under 1 permit, essentially. So that's going to change, and you know, I'll talk a bit about context, I think, as I move forward, and you know, what that's going to look like from a water well drilling perspective and a geothermal driller's perspective. Kind of jumping through, so the slides basically will tell you that you know, there's very little that we have to do right now to do geothermal. You know, David said that the tax credits are pretty much in play. There's a finite number of years out in front of us for the first time in a very long time that, you know, this thing's going to get some traction. Data centers, again, is going to build more traction. What does that mean as practitioners that are trying to protect the resource? Well, guess what? There's way more opportunities now than perhaps there have been in the past for us to mess things up. Hence my desire to be part of rules and regulations, hence my desire to take my drilling knowledge and you know, help benefit the resource if I can. Current rules and regulations, we have water well contractors are under one set of rules. Again, we have, by statute, it says don't mess it up. But there's a really strong lobby that says, as a contractor, you know, so long as my paperwork is correct, I don't necessarily have to do it per the standard. So what I've tried to do in my infinite wisdom is find a way to say, let's build it in a fashion that it's easier to be successful. And anyone who's spent any time on a drill rig will understand that, you know, if you're playing really close to the edge, you're going to get bit. If you're playing outside with some large margin for error, you're going to be much more successful. So I've kind of taken that methodology in all of my activities related, and I'm going to try my best as one of 6 people on this board to lean them in a favorable direction to say, hey, let's focus on the resource first, focus on building the product second, and as much as I hate to say it, the consumer at the end of the day will have to burden or will be burdened with the cost. I think when you look at that dichotomy, you look at that question, why should the consumer be burdened? Well, because if this consumer isn't burdened, then all the other consumers beyond them will be, you know, exponentially more burdened. So, future past potential controversy, that's kind of where I'm at with my challenge. Colorado, as much as we love to speak about Colorado, you know, Governor Polis, he's a good guy, he's a businessman, he gets it, but he's a politician as well. So, you know, I can raise my hand here and say I'm one individual on the board. I certainly can't speak for the board. I can't speak for the state of Colorado, but I can speak to the integrity of the individuals that are associated, and everybody wants to do the right thing. There's a lobby. There's a lobby out there that says we don't necessarily want to do it what they consider the hard way. And you know, frankly, we've discovered, those of us that spend enough time on a drill rig, that the difference between the hard way and the easy way sometimes is just a larger borehole. And sometimes it's, you know, the best opportunity is to turn the drill rig off, step out back, get a drink of water, and just think about it for a little bit, right? Some of the best problems are solved when you turn the machine off and just think. So what I'm trying to do is you know, bring those ideas, bring those concepts, let them understand that if we build a good product and we provide a good service for our customers, and the rules and regulations require that we do certain things, then as a contractor, right, and we're contractors up here, as you know, anyone who's involved in business, money falls from the sky at that point. Money falls from the sky, and it's the regulator's fault, right? So we can all point to the regulators in the room and say, well, they told me I have to do this. Well, the reason that they told you have to do this is because it's probably proper. It's both morally and ethically correct to do it the right way, because we're looking out for the future generation. So we can do a lot of damage if we're not aware, or at least, you know, cognizant of the challenge. It's not going. There we go. Regulatory framework. We're going to work on, this is going to get really interesting. We spent 2 years on the last set of rules. We actually signed a new set of rules into law, went into effect January 1st of 2025. We spent 2 years on modifying existing rules and regulations for water well contractors. And water well contractors have a pretty, you know, well-defined set of rules, at least in the state of Colorado. You know, most states have a pretty respectable set of rules. We spent 2 years putting a revision through that really did nothing, in my opinion, but to make things more complicated. We didn't simplify the process, we made the process more complicated. And in doing so, we created this huge layer of ambiguity out there in the water well contracting community that said, you know, geez, I don't know what I can do. I have to call my regulator for everything that I want to do, right? Is that a good place to be? Maybe it is, maybe it isn't. But add geothermal to that, and the fact that the geothermal guys have been able to drill as many holes as they wanted anywhere on the property, generally speaking, so long as they filled out a report at the end of the day and said, this is what we built and what it looks like generally on the property, So imagine the challenges that I spent on rules and regulations, and now I'm going to bring a whole generally unregulated industry into the water well business and find some common ground. Well, what does that mean to me? That means that the water well contractors are going to say, well, geez, we have to play at this level, and the geothermal guys say, well, we've always played at this level. You know, I want to bring everybody up to this level. So it's going to be a really difficult and arduous task to get that done. Right now, House Bill 25-1165 in the state of Colorado says, by the way, BOE, you guys are going to do this. We've got a great group of staff. We've got Division of Water Resources, Kevin Donegan. Many of you guys probably have met Kevin. He's a great individual for the project. He's a great individual for the task. But the dynamics associated with doing what we're going to try to do essentially in a small amount of time is going to be tough. Right now, the verification mechanism, like I said, the water well contractors, the gray area that we created in the 2025 rules, they allowed the water well contractor to basically learn how to fill out the paperwork, you know, the way the paperwork should read. Now, in the real world, Ben, David, myself, we can all attest in the real world that what we put on paper isn't always necessarily what we see in real life on a drill rig. It's challenging out there. So the objective has always been, how do we build enough room for error to allow for these things to happen? My personal opinion, if you wanted a meme, if you wanted like the superhero in this scenario, I call it grout. It's always been grout, right? It always will be grout. I think anybody who disagrees in this room hasn't seen just exactly what the lack thereof will do to a water well in short order, especially when you get into karst topography, you get into, you know, isolated sections or confining units. You can do some really dangerous things out there if you don't pay attention to what you're trying to do. Verification right now, ideally, I think what's going to happen, they'll do a sole source permit for each borehole. I think the borehole procedures, what they're going to allow, and again, I'm one individual that's speaking, you know, as a member of that board. I think the direction that we want to take is we want to make it more conducive to success, right? We want the water well drillers, we want the geothermal drillers, we want them to make money, right? We're contractors. We all need to eat. We all need to, you know, get our kids through college. We all need to, you know, put tires on the car, right? But at the end of the day, we need to protect the resource. We need to take care of our employees. We need to provide the benefits to the association and society. Potential controversy, I've kind of been talking about it the whole time. It's not going to be an easy task. Is there anyone in this room that thinks that there is a better way to grout than is currently being done in the nation, right? Pardon me? Surface grouting. So let's just talk about surface grouting. We won't even talk about confining units. So let's say from 0 to 40 feet into the bedrock, we all know that, you know, absent that confining unit, we put a open hole into the ground, and we've just created a conduit for things to get quickly to whatever we may or may not want them to get to. Shallow surface water is a whole different thing, but shallow surface water, depending on the environment, depending on the placement, if it's high energy environment, it can get there pretty quickly too, but it does at least have some mitigating factors, right? It's got some finer sands. It's got some, you know, material that isn't necessarily an open conduit. Well, what a borehole does is make open conduit. So grouting is, for me at least, key. You know, the people that love me know it's all about grout. The people that hate me know it's all about grout. Follow the progress. There's some really good stuff online at Division of Water Resources, State of Colorado. I think State of Colorado, I think at least, I hope at least, that we can provide maybe some framework to say, how can we start doing some of these larger projects that David's referring to? I know Ben's going to have some stuff coming in, you know, down the pike here in Montana. I'm hoping that we can at least provide some guidelines and some framework to say, hey, we can effectively do, you know, we can walk and chew gum at the same time. We can do geothermal and we can do water wells, and we can do both of them equally successfully. We can make money at it, and we can make the regulators happy. You know, so I'm unique. I wear a number of different hats I'm a regulator, I'm a, you know, yeah, I'm an opinionated regulator who actually has to make a living, right? So that's a contractor. Future outlook, check the website. Outcomes and conclusions, stakeholder meetings are underway right now. I think Kevin has the latest revision. I try to stay away from it. I've been so involved in rules for so many years. I really don't even start looking at what they're doing until it gets close to the end, because there's going to be a whole lot of back and forth. There'll be 50 or 60 revisions before it gets to us at the board level, and then there'll be another, several months of controversy to get us where we want. The one thing that anybody who knows me, and many of you in the room, I think I've met in the past, David and I, we go way back. We've been a lot of places together. We've done a lot of different stuff. The conversation that we always have is, at the end of the day, let's do it right. Let's have fun. So thank you.
And last speaker this session will be Ben Minden from Pat's Drilling Company Incorporated, and he's from Belgrade, Montana.
Good afternoon, everyone. Like he said, I'm Ben from Potts Drilling, down just outside of Bozeman. Unlike these two distinguished and very knowledgeable gentlemen, I am neither distinguished nor too knowledgeable. But I just kind of wanted to tell the story here very briefly of my background and how I ended up in the drilling industry, and a couple takeaways, lessons learned. I did not grow up in the drilling industry, nor have I ever been exposed to it until a few years ago. And so, part of this is just kind of my observations as someone who's new to this whole world for the last couple of years. But yeah. So quick kind of layout of what I'll talk about, a little bit of my background, a little bit about what Potts Drilling is and what we do, a brief story about buying Potts Drilling, a couple lessons learned from the first 2 years, and then some takeaways. So my background, like I said, has absolutely nothing to do with water well drilling. I grew up on the East Coast, went to West Point and have a degree in mathematics. I absolutely did not use that. I commissioned as an infantry officer in the Army after that, and then served in the 101st Airborne Division, which, if anyone's seen Band of Brothers, it's that kind of old famous unit. That's a picture on the bottom right of us in Afghanistan, and then moved over to 3rd Ranger Battalion, which is the Army's Special Operation Raid Force. And that picture up there is us in Iraq. So, like I said, did not use the mathematics degree much in that experience. But my role was as a platoon leader. So I had a group of 30 to 40 gentlemen that I worked with, and kind of got to go all over the world, do a bunch of really fun stuff. So that's my background. And then Potts Drilling's background started in 1962 in Bozeman by Herb Potts. Was kind of one of the original water well drilling companies in southwestern Montana. In 1992, Dave Potts, Herb's son, bought him out, which year I was born, for context. I say it, Potts Drilling is the best water well drilling company in all of Montana, and kind of in that part of the state, the preeminent dual rotary and kind of full service pump company. We run 2 foremost DR drill rigs and 3 pump trucks, and we have 13 people working at the company. So that's just a little bit of context about the size and scope of what we do, and a lot of the stuff that these gentlemen talked about is applicable to us. We drill residential, commercial, agricultural, geothermal, and do the pump systems for all of them. So we have 2 very different, distinct halves of the business, which is the drilling and the pump side of things. So, as I said, I spent 10 years in the Army not drilling wells, and was building my house and started calling around to get a well drilled. And everyone I called told me I had to wait a year. They wouldn't tell me when they would show up, and it was a crazy price. And so anyway, for one reason or another, Potts Drilling came out and drilled the well for my house, and I was super impressed with them and said, I can't believe you made me wait a year for this. You showed up, did all the work in one day, and charged me this amount of money. This is the most interesting thing I've ever seen in my life. And so I called Dave Potts, kind of half jokingly, and said, I don't know what you guys do, but if you want to sell Potts Drilling, I'm your guy. Fast forward, I now own Potts Drilling, so joke's on me. But so what kind of made it interesting from the outset to someone who is not from this? And I spent the vast majority of my adult life in southern Georgia with a bunch of old ranchers hanging outside of military bases who were very anecdotal and astute observers of the world. And so when I had this one experience with this drilling company, I thought that's pretty interesting. I don't know of any other profession in the world where you can call anyone who is listed to do that job, and they all tell you have to wait a year to get it done, and they won't let you know when they're going to do it. And it's something that you need. So I got really interested in the industry and just thought it was something worth checking out, and so I kind of dug a little deeper into it. The kind of second thing that piqued my interest with Potts Drilling was the attitude of the gentleman who drilled my well. They showed up, the trucks were shiny, they were super professional. I wouldn't do this now, but I didn't know the rules back then. I offered the guys a bunch of beer because it was hot out, and they were like, we have CDLs. It's very bad to be running the boss equipment while drinking beer. I thought, that was good. There's a lot of people who would have drank that beer. And then as we kind of got into the process of buying the company, Dave Potts, who has become, like a second father to me at this point, he is obsessed with recording and organizing, 60 years of the company's information. So I got interested in kind of the broad industry, and then really was impressed with just the little that I had seen at Potts Drilling. And then as we kind of got into the sale process, Dave was just super organized, and I mean, he has records on every well that Potts Drilling has drilled in the last 65 years. And it's all organized and easy to find, and I thought that was really impressive too. And so and this was, 4 years ago now when we were going through all this. Looking back on it now, what makes Potts special from my perspective is Potts Drilling was a water well drilling company, not just a person who drills water wells or happens to have water well drilling rigs. And so that, reflecting back on it, is kind of the golden ticket it was for Dave and it was for me, that there were people and systems and things in place that allowed someone who had no experience to kind of jump into the company, allow Dave to half retire, and then kind of gave me an opportunity to get started on the right foot. And so what I was hoping for was exactly that, which is to be able to jump into a team and kind of hit the ground running and not mess it up. And yeah, just a little bit about the process. And I think this is part of a broader conversation that a lot of water well drillers in Montana are having, is how do you take 60 years of institutional knowledge and pass it down to the right people who can capture that and keep it going for the next 60 years, hopefully. And so the process of doing that, I'll get into a little bit more on the next couple slides. But so a couple just lessons and where we're at now for Potts Drilling. And again, this is probably not news to anyone in this room, but knew nothing before, 4 years ago, so this was all very newsworthy to me. The number one thing is that I think in the water well drilling and maybe contracting at large, reputation is everything. We have people call every day who Dave's dad drilled a well for them in 1963, and they had a good experience. And now their kid is building a house, so we're going to drill the well for that house. And it goes both ways. If you have a bad reputation, it works equally well against you. And so the importance of reputation, I think, is kind of the number one thing worth protecting. The water well contracting world is a very tight-knit industry that takes a lot of pride in it. The other day, we were drilling a well next to another drilling company in Bozeman, and one of their guys was out sick, so I actually helped, like, our number one competitor drill a well for the day. So it's a very, very tight-knit community of people who are kind of all working towards the same goal. It's got real stakes, like these gentlemen talked about. There's a lot that can go wrong drilling a well. It's a big responsibility to punch a hole into the ground, and there's a lot that can go into that and a lot that can go wrong with that. And so it's real stakes, which I find enjoyable and meaningful. Next kind of lesson is that there is a lot that goes into drilling a well. A lot, especially when you do all the different things that we've talked about kind of here so far, water wells and big municipal wells and geothermal wells and all kinds of fun stuff like that. Dave Potts says it all the time that he is still learning something new every day, and he's been doing it since he was 6 years old. So that's something that I have a lot of pride and joy in, is that hopefully doing this for a long time, there's always something to learn about drilling the wells. Good team makes all the difference. Like I said, if I had bought Potts Drilling and Dave went to Tahiti the next day and laid on the beach, it would be closed right now. And luckily, he had the foresight to build a real team around him, people managing different parts of the business, people with institutional knowledge, who I was fortunate enough to have stick around. So a good team is kind of the key to, I think, having a really good water well drilling company. Process solves a lot of problems is one of my big takeaways. Like I said, my background, if the person who knew the radio frequency for the helicopter died and no one else knew that, you just weren't going to be able to talk to the helicopter, so everyone kind of had to know all the stuff. That's something that I've stressed a lot in the last couple years at Potts Drilling, is that if you're the only person who knows where to order this obscure part from in Iowa for this multi-million-dollar drill rig, and you get hit by a bus, or your mom is sick and we can't get a hold of you, like, it kind of shuts us down, and then we can't help people get back in the water, do any of that stuff. So we've spent a lot of time on the process of recording all this institutional knowledge that has been captured over the last 60 years, making it accessible to everyone, and making sure everyone knows how to find it. My goal is that anyone at Potts Drilling should be able to do anyone else's job at Potts Drilling at any given time. Because I think probably 10 years ago, like if Dave got hit by a bus, Potts Drilling would cease to exist. So we're working to avoid that problem in the future. Kind of last lesson learned is that it's super satisfying work. I feel lucky that I've had 2 careers, and both of them have been really enjoyable. And this one's just as fun as my last one, and get to do really meaningful work with a super awesome group of people. So where we are now, we've been able to kind of hit the ground running, and we've grown about 50% in the last 2 years, just saying yes to more stuff, stressing ourselves, taking on different kinds of work, and jumping into the geothermal stuff head first, and all kinds of fun stuff. We're continuing to build the team, which I'll talk about a little bit later, and then diversify within the team. I think is a super big driver of why we've been able to continue growing. When I got to Potts Drilling, we have 2 drill rigs, and there are 2 people who could turn them on. We still have 2 drill rigs, and now we have 12 people who can turn them on and run them. And so that is something I think that has been really helpful for us. So when someone's on vacation, that drill rig doesn't just sit in the yard for 4 weeks or however long they're gone for. So diversifying what people can do within the company has been helpful for us. And then also I think it's engaging for people to cross-train between pumps and drilling and being a driller's helper and actually getting to run the rigs. So that's been super helpful. And then kind of the last thing is, again, my background, people coming into the Army have never been in the Army before, and then you put them through a process and they theoretically all of a sudden know how to be in the Army. We've kind of applied the same thing to Potts Drilling, whereas I think traditionally a lot of drilling companies, they want to hire a driller and they put an ad out and say, you need to have a CDL and a driller's license to work for me, which there are 100 people in the state of Montana who meet that criteria. For us, we're willing to take a ranch kid who has seen a pipe wrench before, put him through a multi-year process, and get that person the skills that they need to do the work the right way. Couple takeaways, I guess, as we think about the water well industry's aging population of contractors. There are ways to pass down valuable companies with institutional knowledge. It takes a ton of work, but if you have a willing buyer, a willing seller, and a company, you can hopefully make it work. I think, as far as I know, Dave and I are the only people who have probably successfully made this type of transition that and either of us know of in Montana. So it's definitely possible to do. With that, a team is worth more than a piece of equipment. And so I think a lot of people, their plans when they go to think about slowing down or to just sell their piece of equipment, change the answering machine, and that's it. They just stop drilling wells, which is a real shame because the amount of learned experience and knowledge a person like that takes off the table with them when they leave is really damaging. And so if a person is thinking about this and you can build a team around you instead of just having it all reside in your head, that is worth a lot. There seems to be more drilling and less drillers. If you plot the amount of footage Potts Drilling has drilled since 1962, it goes up every year, and the amount of drillers in the state of Montana continues to go down because it is, there are, more people own drill rigs than there are drilling companies that can easily be passed down. If you're deliberate about passing down knowledge, there is a way to capture it. Again, it takes a ton of work and, a process to capture what is inside someone's head or 10 people's head and put it in a place that's accessible to everyone and in a way that someone with 5 years of knowledge can perform the way that someone with 20 years of knowledge can. There's more help than people think. I saw before we were talking that workforce problems were kind of one of the big things on people's mind. Another anecdote, when Dave and I first started talking, I asked him how many days a year do these drill rigs drill wells? And I can't remember what the number was, but it was half the year, let's say. They're actually out drilling wells. I said, why wouldn't you just hire some more people and then the drill rigs could just drill twice as much? And he was like, well, it's impossible to find help. And I asked him, well, what is your process for finding and training people to run these drill rigs? And he said, well, if I'm sitting next to someone at church or I run into someone at the coffee shop, you know, and they have a kid that might want to do it, you know, maybe I'll ask him if they want to work for us. I said, well, have you put out an ad? Like, and I mean, he had never put out an ad on Craigslist or Facebook or the newspaper or anything. And so that is, we have since put out some ads and found some really awesome people who now work at Potts Drilling, continue to work at Potts Drilling. And so I think, I'm not sure that's the perfect solution, but there, you know, my sample size of one try has shown that it's not as hard, I think, as people make it out to be, to find good help if you're willing to deal with a couple years of pain and suffering to train them. Guess final takeaway is you don't need to grow up in the industry to jump in. So it's been a blast. I'm happy to be a part of it. And yeah, thanks for your time.
Thank you for 3 great presentations. We have plenty of time for questions, so does any from the audience? Oh, there they are in front of me. How about that? Well, first one's from Steve Wilson. It's not a question, but Ben, thank you for your service. Todd, is there a benefit to geothermal over non-potable water reuse in Colorado? No? It's green.
I guess I don't really fully understand the question, the benefit to geothermal over non-potable water. I think, in my opinion, the challenge is, you know, we're trying to do the same thing with the same resource. And my objective obviously would be, you know, do no harm. So is there a benefit? I think to David's point on the technology, there's some new technology that's going to say, hey, instead of pump and dump or you know, do in-loop or in-ground heat source loops, we can benefit using the earth and the water potentially without using any of the water. I think a lot of the geothermal rules in the state of Colorado, you know, greater than 2,500 feet is going to be a whole different set of regulations, but less than 2,500 feet, I think will allow for us to basically use that water without actually using it. So use the mass, use the storage, use that level of transmissivity within the system itself without actually taking it out of the ground. I don't know if that answered the question or not, but that's my opinion. And one thing I wanted to say before we get too far along, Ben, there is hope for this industry. I met Ben less than an hour ago, guys. I met Ben when most of you guys met Ben today. I've been involved in this business since I was 20 years old. I'm 67 years old today. I love to see people like him cut their teeth in this business, much like I did. He's got a level of enthusiasm. He's got the right ideas. He's got, early on, I think, what is the start to be a very long and successful career in this business. So thank you, Ben. It's a breath of fresh air. I love to see it. I don't get to see it that often. Everyone in the room, they talk about, you know, the labor pool, the challenges that we have. But to see Ben come with that attitude and that mindset and understanding that a mathematician can run a drill rig is a good thing.
All right, David. As data centers no doubt keep growing in size over time and the demand for cooling water increases, is there anything in the cooling process that has added anything that the water being, is there anything added, anything to the water being used like TDS?
Well, all the geothermal systems that I talked about are 100% closed loop. So they are 100% separated. The building is 100% separated from the water resource, which is really kind of a novel thought that we're able to, you know, use groundwater as an enabling force without functionally adding things to it or subtracting it from the ground. And some of these systems actually have a lot. So you think about, you know, potential impacts. Closed loop systems are really inert. Submerged closed loop heat exchangers don't even pump groundwater out of the ground. Pump and injection systems, yeah, you've got to, anybody who's ever dealt with injection wells knows that you have to manage injection wells. So there's some, things from that end, but as far as additives, there shouldn't be, there doesn't need to be.
Thank you. All right, and this is for everyone. From your experience, how can drillers and researchers / state departments / extension programs better work together to reach well owners to encourage well management practices and prioritize water quality and health? Anyone want to take a stab first?
I've got a 5-minute lightning talk that is going to solve all of your problems to that question tomorrow. It's something that I've really struggled with over my career, and that's now spanning 16 years working hand in hand with the Department of Health to try to understand this. And we've got a really good hand-in-hand relationship. Todd talks about his Board of Engineers experience in Colorado working with regulators, but I think one of the things that I see is that as more people get involved, especially extensions, especially other community groups, everybody ignores the fact that there's a group of people that work with well owners every single day and have built really good relationships with their customer base, and they have a tendency to either overlook us, not know we exist, or keep us out of the conversation somehow, or don't think to bring us to the table. And I think that people have to think about, they have to know your contractors. This is a people-to-people industry. Ben in 2 years has figured that out and has done a great job of knowing that I need to know people and I need to really build good relationships with people, and they're really beneficial because you need each other in order to get it done. Just like Ben helping literally one of his competitors complete his project, because that's the weird thing about our industry. The only people that can help us with our problems are our competitors. Okay, that's it. There is no other knowledge base. And so trying to get involved inside of that ecosystem, be part of those groups and relationships will help you then reach those well owners, because we don't know what we don't know, right? We spend our days solving really complex problems, making the things happen. A lot of you guys get to spend a lot of time dealing with research, dealing with papers, dealing with other knowledge bases from all over the country. We don't get to see that. And so how we figure out how to pull that together in a collaborative body to help the people who are out working to understand. Arsenic is my favorite example. Went from 50 to 10 overnight. Why? Well, because. And there was never really good explanation to our level as to why it happened. But as you start understanding the health effects, what it is, the fact that 10's not far enough, and really, there's this range, at least at 5, probably less, that people should be concerned about it until you start helping people understand. And this is coming from someone who can pick stuff up pretty fast. It took a while for me to actually get enough information to understand how to communicate that to my customers. And if we can understand that how piece, we have a tough time communicating it out to them. So, thinking about those information resources and how to be it and how to grow it and help contractors be more knowledgeable and comfortable having those conversations, it's a real challenge.
A lot of what David said is exactly right. We don't know what we don't know. But what we do know is there's not a question out there that any one of us will contemplate that we can't reach out to an individual in the room. We can't go to a seminar like this. I mean, I've been all over the world with these things over a very long period of time, and the one thing that I can honestly say, I learned something at every one of these conferences. And you meet people, and those people, know people. At the end of the day, you have a much larger group to draw from. You can say, hey, remember that talk that we saw in Harrisburg, Pennsylvania in 2017, whenever that was, right? You remember those things, and you can reach out to those individuals, much like we do with our competitors, and you can get those answers. I think one key point that everybody needs to be aware, and I think it was at Shannon earlier, said, your customer or your client, they got to like you. They got to feel comfortable, right? They have to know that you're a reputable source or resource, right? They need to understand that you're a trustworthy individual with everyone's best interest at heart. And I think half the battle, at least as a contractor, is how do we portray that? How do we exude that enthusiasm, right? How do we learn from our own mistakes and make it better with the understanding that we're just people that work with people. So that's my take.
I guess my take on this is probably the vast majority of the responsibility falls on the drilling contractor to construct the well properly. I think if you can do that right, you take out 80% of the things that could jeopardize water quality or health. One thing on the regulatory side, you know, again, just speaking with experience kind of around Montana, Idaho, and Wyoming, everyone has different, I guess, descriptions in their rule books for how to grout a well. I don't know that I've ever heard consensus on what the best way to do that is. In Idaho, they take it a lot more serious than the regulators take it in Montana. I think if an easy fix for any state would be to get with someone who's really experienced in how to, like, what the right way to grout a well is, make it a rule, and then make people follow it. I think that would solve a ton of water quality issues. Another just tactical level thing I think researchers and state departments could do to improve water quality. You know, in the state of Montana, you don't need any kind of certification or licensing to put a pump in a well. You need, you know, all this crazy stuff to become a driller and a contractor, and then, you know, Joe the farmer can buy a pump truck and put a pump in the well, and he could set that pump on the ground where a dead cow was laying yesterday, and then stick it down in that really nicely constructed well that you just drilled and contaminate the aquifer. So I think, I'm not sure what it's like in other states, but if, you know, that, I think that would solve a bunch of it too, is if there was some regulation or licensing around the pump side of the water well industry.
Keep it. Next one's for you.
Go.
Oh, it was. Oh, sorry. It was, until I said that. This doesn't have a direction, so anyone can take it, but what are some ways that the state and extension professionals can establish those beneficial relationships with the water well drillers? Any of you want to take that?
A couple of ways that I've seen it happen is almost every state has a water well convention. Almost every single one of the groups has a convention where they get together, participate in continuing education, trade show, and meetings. And so the easiest way is to go to one of those and meet some people. And you don't, you know, honestly, you need to start with one, right? Make a good relationship with one person. That person will help you meet the other people you need to meet, because there's those of us that do want to participate, like 3 people up here, and then there's a lot of other folks that are uncomfortable, or you'll get them on the next round. And so just being able to be in those places can help build those relationships, but you do need to reach out. I mean, as like Ben was telling, about a year backlog, people constantly calling, 24/7 service, trying to keep on top of everything. It's hard for us to make time, the contracting industry, to make time to really reach out and know how to engage the conversation. So it's incumbent upon extension groups to really get out there and meet with contractors, learn the differences in the different areas, because every state, every corner have slightly different practices, slightly different problems, and slightly different things that they're trying to, you know, work around, whether it be water quality issues or material availabilities or other things like that. So understanding some of those intricacies goes a long way, and be able to really participate in good conversations around that.
Anyone else?
I would just say the easiest way people can establish relationships with drillers, stop in the office. Like, if we have people come by all the time, and sometimes we'll see stuff that gets written by the DEQ or DNRC in Montana, and the thought is certainly they did not talk to a driller about this, because, you know, this verbiage doesn't make sense or anything like that. If someone from any of the extension offices or regulators wanted to come out and drill a well with us for a day, we will put you in welding gear, and you could do it, and you could see what the process takes. And it would be, I think, super beneficial and very easy. And I guarantee any driller in the state would let you, a regulator or an extension person just come out on the drill rig and see the realities of what all that is. It'd be, super easy to just swing by or call and find someone to go spend a couple hours with on a drill rig. And I think a person could learn a ton.
All right, next one is for anyone who wants to answer it. Have you or do you see private well owners asking you about their water quality?
Yes. I mean, for someone that's been doing this for 30 years, it used to be about, is there something wet coming out of the faucet? I would say about 10 years ago, people really started teasing into what was coming out of their faucet. And with the evolution of PFAS, that's only increased people's, the questions they ask and their concern over it. I will say, this is the thing that I've tried to unravel, because I've heard it in at least 3 talks so far about testing. I think one of the things everybody needs to think about is, where are we going to test all these samples that we want people to do? Because the NELAP standards make it very hard for rural areas of the country to afford the personnel that it takes to make a lab. I've been talking about this for a decade, okay? And I don't know why it's so hard for people to understand that if you have to have the kind of credentials to be accredited as an environmental lab, and you think you're going to be in Starbuck, Minnesota, doing that with this very limited range of analytes that they're going to be working on, it's not a recipe for success. People in this room really need to be pounding on this table saying, we need labs that can help private well owners that analyze the things that we need them to be checking for. Because as we talked about, there's drop boxes, there's this, but there's timing, there's all these other things that go into water sampling, water testing, and you're not gonna be able to control it in such a rigid environment. And so I think, yes, people are really curious, but we need to make sure that they can actually get out and answer that question and not make it a day-long ordeal to collect a sample and drive it to a lab 3.5 hours away from where they live.
Anyone else? All right, we'll move on to the next one. This one is for David. Would increasing groundwater temperature potentially result in localized or larger scale increases in concentrations of geogenic contaminants? Are there regulations on proximity of these data centers to the homes and private wells?
So the answer to the first one is absolutely yes. And that is why we need to actually reinvest a little more resources into the research around these systems. It's a great question. I think there are people that know the answer. There's people that have done independent studies that know where the limits are on delta T's in groundwater and where these concentrations start to precipitate. But there really hasn't been, say, like a national laboratory analysis on the matter with real hard published guidelines. So it's one of the things that I would like to see people functionally really look at. The nice thing is most of these systems have limits on the range because they're all predicated on working inside of a refrigeration cycle, which can only hit delta T's of X or Y. But it is something that, it's something that you still need to study and look into and not just take for granted that it can't envelop and grow over time. And are there regulations? Well, I'm sure from the standpoint of, say, most of the systems that I talked about today are net neutral on groundwater, right? So they don't necessarily have appropriations issues in the sense of functional groundwater use. And so your interference claims on like localized private wells, I'm not sure. And the thing that's interesting, even about groundwater enabled geothermal, is that water is a really good heat transfer fluid, but it's a horrible water storage mechanism. So what happens is the water is really kind of a vehicle for the energy to ride along, but the soils are what retain it. So what you'll see, like when you think about a pump and injection system, you'll see the injection well taking all this energy, and you'll see the soils, with the thermal gradient around them. But it's not like it's staying with the water for, say, miles and miles. The earth has absorbed the energy, the absence of energy or the excess energy in the soils around those wells. So good question. I'd love for people to actually come up with a real logical way to answer that question.
Ben, next 3, 4 look for like they're coming to you. Ben, do you think that the leadership skills that you learned serving the Army have enhanced your ability to run POTS drilling and allowed it to flourish? Rangers lead the way. Hoorah!
Yeah, they do.
There's a Marine in the room.
I think yes, they've been very helpful. I think the biggest thing for me is, so for a basic Army platoon setup, you have really skilled and knowledgeable people who have been doing it for 10 or 15 or 20 years, and then you have a very young platoon leader that's typically in their early 20s who is technically in charge of that group of people. So to be successful at that, you have to enter into this group of people that have been together for a decade and know all the answers, and then you're supposed to figure out how to get things done with them while basically knowing nothing. That's pretty much exactly what I did at POTS, right? The person who had been at POTS the least amount of time when I got there had been there for over 10 years, so it's super tight-knit group of people. They're all technical experts, and you know, I think the probably number one lesson from my experience in the Army is, like, if you just don't have an ego, I'm not pretending to know more than these other people. That is the thing that they're really good at. That I am good at making sure the insurance is paid and the taxes are on time and all the other stuff that I'm supposed to be doing. And so that, you know, having roles and not attempting to make it seem like you're supposed to be a person who's a technical expert when you're not, has been super helpful. And then one thing too on this, my dad's a carpenter, and again, build my house, and I was using a tool upside down, and my dad said, you know, you're using that tool backwards, right? And I was like, yeah, but it's faster and better to do it this way, so I don't care if it's backwards or the right way up. And he said, you're lucky that you don't have the burden of experience. And that has stuck with me because it's been like something that's been super helpful to me. I don't have the burden of my dad having drilled wells this way and then me drilling wells this way. I just think that from the Army and all that stuff, I can just solicit good opinions from a group of people and we'll just go with the best one. So there's no pride or ego in it, and I don't have the burden of experience. So it allows us to maybe do things a little differently or faster, things like that. So
Excellent. And this will probably be the last one based on the time. And this was the one that was at the top. I gave the microphone, then all of a sudden, 6 minutes altogether? Okay. So Ben, what are the barriers to keeping more people and companies from getting into well construction?
I think the biggest thing that keeps people from getting into well construction is well drillers. It's a very particular subset of people. Take Dave Potts, for example. He grew up, Bozeman was not an economic hub. You're drilling wells in February in Montana to feed your family. It's, you know, you had to be really particular with your stuff. These are, you know, to get set up with a new drilling rig and all the tooling and support truck and everything that goes with it, you're into it for between $2.5 and $3 million. And so, like, to take care of that stuff, if you're the one paying for it, you want to be the one taking care of it. You want to be the one making sure you don't hit a curb and get a flat tire and you're out $800. And so my experience, having been around a lot of drillers at this point, is the drillers are the number one thing. They tend to not be able to get out of their own way to let someone else run the drill rig. And it's not terribly complicated. There's like 10 levers you need to know what they do. So like the physical act of running the drill rig is not tremendously complicated. The knowledge that goes with how to do it the right way and when to do what is the complicated part. But my experience is that people who grew up drilling are so particular about the equipment and the wrench goes here, not there, and the screwdriver sits here, not there, that they just can't let other people, younger people, touch the equipment. And then all of a sudden they're 68 years old and no one else has ever touched that piece of equipment. And then no one knows how to run it, and they sell the piece of equipment and shut down. And so that, like, I think if drillers could get that out of their way, that like at some point you have to let someone else do the thing, that would solve a lot of this. And then the second big one is just, it's a very, very, very expensive industry to exist in. I don't honestly know how someone could start a well drilling company from scratch at this point, unless you had a trust fund, but then why would you be a well driller? So that's my take.
Dave, do you think you can do that in 3 minutes?
Sure can.
All right.
But I do want to tag on the back end of Ben's question, because this has been what I've felt is like the fundamental problem as I've grown up and watched this industry and gone from being the young guy in the room to being a little bit of average, at least average age guy in the room. There's some real financial hurdles to operating these companies. The complexity, depending on what states you're working in, make it even more challenging. There's continually evolving, we'll call it other agencies or other requirements or other things that kind of keep on raising the bar. And if like Ben said, if you're still stuck on the drill rig, it's hard to do the other spot. I mean, companies don't run themselves, right? They take administrative capacity, and a lot of that, well drillers are really great well drillers. They're not always really great business people, okay? And so when we think about perpetuating these companies, helping people understand, like Ben, Dave Potts is honestly one of the best of us, period, coast to coast. Dave is, how I met Dave was over the phone when one of my trucks was drilling in Big Sky, broke down on the side of the road. Dave called his guys, they hooked up to trailer, hauled some stuff down the hill for us, because we're going up these switchbacks up into the mountains it was Yellowstone. What is the housing just north of Yellowstone? Yellowstone Club. Yep. And he hauls it down. I call him like, hey, you're gonna send me the bill? He's like, no, we don't. We just help people out when they need it. And that's, having people that have that mentality to pay it forward and have the organizational capacity and the people that have stuck with, it's just not super common. And so even finding the companies that can perpetuate is pretty rare. So how do we grow that skill set? It's working with associations, helping them understand the higher, kind of these next steps to having perpetuation in companies. It really is going to take a lot of effort. And frankly, we're out of time in a lot of cases, because people are, you got to think this stuff takes 5 to 10 years. And so you might have missed the opportunity in some cases. So you got to think about what you can do with what you have left and the time you have left. And water quality, thermal pollution, all of this stuff is controllable. It's just a matter of having intelligent engineering. Was working on a loop field not too long ago. The thing was way heating dominant, and so they didn't have enough room for the loop field. And I'm looking around saying, all right, well, this isn't going to work with what you want to do. I'm like, what's that building over there? And they say, oh, that's an ice arena. I said, problem solved. Ice arenas do nothing but reject heat all year round. They're worse than data centers. So you hockey fans, just be on notice. We have to think about more creative ways to deal with, especially with the rise of electrified heating and cooling systems. We have to think of more intelligent ways to handle that thermal pollution thing that we're thinking about, because it doesn't have to happen. And on top of that, everything we put in the ground, if you think about, if we use the earth as a thermal battery, there's nothing that says in the evenings and off-peak hours in the dead of winter in northern climates that you can't turn these systems on and recool the earth using basically kilowatts that functionally wouldn't have been used anywhere else. There's intelligent ways to handle all of this, but it's going to take people talking about the problems and the solutions to really move beyond where we are right now.
All right, and we're going to have to cut it there, but please give a round of applause to our David, Todd, and Ben.
Big thanks to Ben, though. This is your first time being stuffed on a stage, right?
Yes.
Yeah, so good first run. Thanks, Ben.